morning, dear students. Today we are going to start a new chapter, that is physical and chemical changes. Okay, so in this chapter we are going to study what is a physical change, what is a chemical change. We are also going to study few examples related to physical and chemical changes. We are also going to study certain types of chemical changes. Okay, so in this particular chapter, basically these are the topics that we are going to cover, right? So let's get started with the chapter. So introduction. Every day you come across many changes in your surroundings. These changes may involve one or more substances. For example, your mother may ask you to dissolve sugar in water to make cold drink. Making a sugar solution is a change. Yes or no? So all of you must have seen how lemon juice is made, or how different types of juices they are made. So when you make juices, what you do, suppose you want to make lemon juice, right? You take some water, you take a piece of lemon, you squeeze the lemon in water and you add some salt and sugar, right? So when you add some salt and sugar, you dissolve the salt and sugar. After that you will see that can you get the salt and sugar, can you get the original salt and sugar back? No, it is not possible, isn't it? Normally. But yes, there are some processes by which you can get it back. But it is a change, yes or no? Yes, so first that water was plain water, now it has become lemon juice, right? So it is a type of change, okay? Similarly, setting curd from milk also is a change. Now when you make curd from milk, okay, so that is also a change, isn't it? So when you make curd from milk, can you get the original milk again? No, you cannot get, okay? So that is a change. Sometimes milk becomes sour. Souring of milk also is a change. Yes or no? Sometimes when you leave milk in the open, you don't keep it in the fridge, it becomes sour. Okay, can you get back the original taste again? No. So it is a change. Stretched rubber band also represents a change, isn't it? So when you buy a rubber band from the market, that is quite tight. Okay, so when you stretch the rubber band, it becomes loose. So that is also a change. You cannot get back the original rubber band again, right? So now let's come to physical changes. Now when you look at change broadly, changes are of two types. Okay, these are called physical and chemical. Properties such as shape, size, color and state of a substance are called physical changes. Okay, shape of the substance, size of the substance, color of the substance, okay, state of the substance, those are called physical changes. A change in which a substance undergoes a change in its physical properties is called a physical change. A physical change is generally reversible. That means you can get back the original substance again normally in a physical change. Okay. For example, the shape. Suppose you have a plastic scale, you bend the scale. Okay. After bending the scale, you can get back the scale again. Okay, you can make it into the original shape again, isn't it? Size, in that way, sometimes the size of a substance, you can change the size, but still you can get the original size again. Color, okay, color sometimes might change. Again, you will get the original color again. Suppose you are heating a iron rod, okay? So once you're heating the iron rod becomes red hot, right? But when you cool the iron rod again it will get its original color. Okay, that means the change in color, the change in size, the change in shape, these are called physical properties or physical changes. Okay, so it is generally reversible. That means you can get back the original change. I'll give you one example. Suppose making of water, making of ice from water. Okay, so when you take water, you keep it in the fridge, you get ice out of it, right? But in ice trays, you keep the water, you get ice, isn't it? When you keep it in a deep freezer. But again, when you keep the ice in the open, doesn't it become water again? Yes. Okay. So that is a physical change and that is reversible. That means you will get back the original substance again. In such a change, no new substance is formed. You will not get something which is completely new and you cannot get back the original substance again. That you will not get. Okay, like for example, when you make ice from water, right? So ice is a new substance, but it is not so new substance that you cannot get back the water again. Okay, so ice and water have the same chemical composition. They have the same chemical composition, it doesn't change. So in physical change, chemical composition of a substance does not change. That is why you can get back the original substance again. Okay. Now we come to the chemical change. Okay. So physical change, you had some activities. Okay. Activity 6.1, 6.2, 6.3, 6.4. Very simple activities. You can just read once, you will understand whatever I explained. Ice from water, then suppose you have a piece of paper, you cut the paper, shape of the paper changes, but does the paper become something new? No. So it is a physical change. Okay, so these activities are there, you just read, but it will not come for your exam. That is why I haven't included them. Okay, activity 6.1 to 6.5, you just go through them. I haven't included them because it will not come for your exam. Okay, so now chemical change. A change with which you are quite familiar is rusting of iron. All of you know rusting of iron, isn't it? A layer is deposited over iron when you keep iron articles in the open. Okay. If you leave a piece of iron in the open for some time, it acquires a film of brownish substance. A brownish powdery substance develops over it. I think you must have seen this in your homes also, those who have iron gates. Okay, if you don't paint the gates, then you will find that a brown kind of powder develops over the gates, isn't it? So that is called rust. Okay, this substance is called rust and the process is called rusting. Iron gates of parks or farmlands, iron benches kept in the lawns and gardens. So when you go to a garden, okay, or you go to a park, you will see benches. Okay, so if the benches are not painted, you will find a powder kind of thing developing over the benches. That is called rust. Okay. At home, you must have seen shovels and spades getting rusted when exposed to the atmosphere for some time. Those who do gardening, okay, you have spades, shovels at home, you will find that those are also made up of iron. So if you just keep it in the open for some time, you will see a layer of rust developing over them. In the kitchen, a wet iron tawa often gets rusted if left in that state for some time. Okay, so nowadays you have non-stick tawas at home where you make rotis, isn't it? But those who have iron tawas, if some of you have, you might know that those get rusted very easily. Okay, that is why you should, wipe the tawa dry before storing it. Because if you don't wipe it dry, what happens is, the tawa, it is there, water is there and it comes in contact with air. So air and water both will react and rust is formed. Okay, so rust is not iron, it is different from iron on which it is deposited. Rust is not iron, it is iron oxide. Okay, rust is called iron oxide, it is not iron. Okay, so iron oxide means what? What happens when iron reacts with oxygen and water? Okay, how rust is formed? When iron reacts with oxygen and water, iron oxide is formed. That is why water should not be there in the iron benches or iron gates. Okay, because if water is there or if it reacts with the water vapor, not necessarily it has to be liquid water, it can be water vapor also. So if iron reacts with liquid water or water vapor and oxygen, okay, it will form iron oxide. That is called rust. So remember, rust is not iron, it is iron oxide. Okay, so we'll continue with the explanation in the next slides.